Welcome to the second component or part of solving an IVP with piecewise continuous forcing function. So recall in the previous video, we were working on solving the IVP y double prime minus 3y prime plus 2y equals f of t for the initial conditions y of 0 equals 1 and y prime of 0 equals -2, where the forcing function f of t was 2 for 0 less than or equal to t less than 5. And t for t greater than or equal to 5. And in the previous video, we rewrote that f of t with step functions, took the Laplace transform of the equation, and then we had solved for y of s. Once we had done that, we then rearranged our y of s into recognizable form. So far we have essentially found our partial fraction components. So we did the s squared minus 5s plus 2 over s times s minus 2 times s minus 1. And we also did 1 plus 3s over s squared times s minus 2 times s minus 1. Putting all of our partial fraction stuff together. So going back to the original problem, we're back to y of s. We have capital Y of s is equal to, I apologize for the scrolling. This is a long problem. Our capital Y of s, we have 1 over s minus 2 over s minus 2 plus 2 over s minus 1. And then our next component, we had a e to the negative 5s times our second chunk of partial fractions. So you'll have an e to the negative 5s times that 9/4 over s plus 1/2 over s squared plus 7/4 over s minus 2 minus 4 over s minus 1. So we have plus e to the negative 5s times 9/4 over s plus 1/2 over s squared plus 7/4 over s minus 2 minus 4 over s minus 1. So from here, we can go ahead and take the inverse Laplace transform to get back to y of t. So we will take the inverse Laplace transform to find y of t. So we have y of t is equal to the inverse Laplace transform of 1 over s minus 2 over s minus 2 plus 2 over s minus 1 plus the inverse Laplace transform of e to the negative 5s times 9/4 over s plus 1/2 over s squared plus 7/4 over s minus 2. I apologize, my screen's not updating. We have e to the negative 5s times 9/4 over s plus 1/2 over s squared plus 7/4 over s minus 2 minus 4 over s minus 1. So taking the inverse Laplace transform of that first piece, 1 over s would just go to 1. Minus 2 over s minus 2 would be minus 2 e to the 2t plus 2 over s minus 1 would be plus 2 e to the t. Then we should have a plus u of t minus 5. We have a tau equaling 5 situation here, times the inverse Laplace transform. All right, let's just go with times g of t minus 5, where g of t is the inverse Laplace transform of capital G of s, and capital G of s is that 9/4 over s plus 1/2 over s squared plus 7/4 over x minus 2 minus 4 over s minus 1. So we need to find g of t. So we have g of t is the inverse Laplace transform of 9/4 over s plus 1/2 over s squared plus 7/4 over s minus 2 minus 4 over s minus 1. So this becomes, we'd have 9/4 inverse Laplace transform. Inverse Laplace transform of 1 over s is just 1. So we have 9/4 for that first component. Then plus 1/2 times the inverse Laplace transform of 1 over s squared is t. Then we have plus 7/4 times the inverse Laplace transform of 1 over s minus 2 is e to the 2t. And then minus 4 times the inverse Laplace transform of 1 over s minus 1, that's e to the t. So we have g of t is 9/4 plus 1/2 t plus 7/4 e to the 2t minus 4et e to the t. We have g of t minus 5, and it's therefore at 9/4 plus 1/2 times t minus 5 plus 7/4 times e to the 2 times in parentheses t minus 5 minus 4 times e to the t minus 5. So putting this all finally together, we get that y of t is equal to 1 minus 2e to the 2t plus 2e to the t plus u of t minus 5 times 9/4 plus 1/2 times t minus 5, or 1/2 t. Then we have plus 9/4 minus 5/2 would be minus 1/4. And then plus 7/4 e to the 2t minus 10 minus 4 e to the t minus 5. We can make this then back into a piecewise function. So writing this as a piecewise function, we have y of t is equal to that first component, 1 minus 2 e to the 2t plus 2 e to the t. This is for 0 less than or equal to t less than 5. Then we have that component, 1 minus 2 e to the 2t plus 2 e to the 2t, e to the t, plus 1/2 t minus 1/4 plus 7/4 e to the 2t minus 10, and then minus 4 e to the t minus 5, and this is for t greater than or equal to 5. Combining or putting that second piece sort of in condensed form, we have y of t is equal to 1 minus 2e to the 2t plus 2e to the t for 0 less than or equal to t less than 5. And then we have 1/2 t plus 3/4. Then our e to the 2t, we have plus -2 plus 7/4 e to the -10th, all multiplying e to the 2t. And then plus, we have 2, and then minus 4 times e to the -5. All of that times e to the t. So this holds for t greater than or equal to 5. Just a quick comment, we could have solved this without using the Laplace transform, essentially by doing a series of IVPs. So we could have solved for the function from 0 to 5 by just solving the initial IVP with forcing function of whatever our original forcing function was. So we could have solved essentially for the, as if we had forcing function 2 and gone from 0 to 5 for that. And then we could have solved for what the conditions were at t equals 5 there, treated those as our new initial conditions, and then solved from 5 on using t equals 5 as our initial point. So you can either do a stacked series of IVPs and solve that way using methods we already know, or we can do the Laplace transform technique. It's going to depend on the problem, which way is faster, but we do have this Laplace transform technique available to us to now solve IVPs. Is a long problem, but we can solve an IVP with piecewise forcing function this way. So that is using the Laplace transform to solve an IVP with piecewise forcing function.